Welcome guys. So today we keep solving our physics subject GRE. So 61, a sphere radius r. Basically you have some charge density and ask about electric field. So because this is just spherical symmetry, so what we need to use is just the Gaussian, the Gauss series. Okay. So we use the Gauss theorem. Basically, what we have is this. Equals to epsilon of total rho. So your rho is this. And what is because is positive at distance r over 2 from the center. Okay, so I should use r over 2 square and r over 2. Okay, so from here we get our answer. Okay, so simple calculation. Answer is B. Okay. So 62, basically you have two capacitors. One is microfarad and another is 2 microfarad. And they are disconnected from a battery and then connected to each other with a resistance so that the plates of opposite charge are connected together. Okay, so basically you have V equals to Q1 divided by Q2, Q1 divided by C1, and Q2 divided by C2. And then you know that C1 is 1, C2 is 2, so Q1 is 5, Q2 is 10. Okay, and then since you're opposite charge, opposite directions, so finally your total charge, your charge will be -5 because you add you use Q1 minus Q2, so you will have these two. And then once you notice that these two need to have the same, still have the same voltage. So really from these two, we can solve Q1 and Q2. So let me see. So which tell you that Q1 divided by 1 is equal to Q2 divided by 2. So Q1 is -5 divided by 3, Q2 is -10 divided by 3. Okay. So which one is the answer? 2 microfarad. What is the magnitude of final voltage? Okay. So basically you have this Q2 divided by 2, so your micro voltage is 5 minus 5 divided by 3 is equals to negative minus 1.7. So the answer is C. The answer is C. Okay, 60. Which is the following composite part object? Answer is A. Muon is a fundamental particle. Muon is a fundamental particle. Okay, 64. The binding energy of heavy nucleus is about 7 million electrons per neutron, whereas the binding energy of medium weight neutron is about 8 million electrons volts per neutron. Therefore, the total kinetic energy under the symmetric friction. So symmetric friction means you have two lights become one heavy. So so it is like 1 plus 1 become 2 is somehow something like this. So that means per Newton you will have like uh 8 minus 8 is total. Okay, but let me see. Okay, so suppose okay, so let me see how to write it. Okay, so suppose this is n, then this is n over 2, n over 2. Okay. And then he tell you that the medium with nucleon is about 8 million electron volts per Newton, and the light is 7. Okay, so basically you have 8 minus 7 close to 1, and then this is the MeV per Newton. Okay. Okay, so for heavy, you ask about for the heavy one. Heavy, maybe 200 is heavy, right? So the answer should be C, close to C. Okay, so 65 men of mass N on the initial boats get off the boats by leaping to the left exactly horizontal direction. Immediately after leap, the boat of mass N is observed to move to the speed. So basically, there's M, and once it there has M move with the speed V. So basically, you have this, and I ask about V bar. So V bar just large M V divided by M. And I ask about the work. So basically, the work is just the total kinetic energy. So it's this. So you have this. Okay. So which one is the answer? D is the answer. D is the answer. D. Yes, D is the answer. Okay, so 66. One is about basically this is the same distance from the Sun and Jupiter. So this is the Sun, this is Jupiter. Okay, and the spacecraft on the mission to the outer planets of the speed. The spacecraft on mission to the outer planet has a speed that 1.5 times the speed of Jupiter in its orbit. So you have orbit. This is v, and then the spacecraft has the velocity like 1.5 times v. Okay, and what is the described orbit spacecraft about Sun? Okay, so the answer must be so remember that when you do the calculation in the you suppose you have the circular motion and gravitational force, then your v is just gm divided by r. And then when you try to escape, your escape velocity just square root of gm divided by r. So it's the square root of v. So square root of v is 1.4 v. So if the spacecraft has 1.5 v, then it must leave Jupiter. But definitely the 1.0 v is not enough to easily escape from the Sun. So it will become the orbit to the Sun. So the answer must be eclipse. Okay, the answer must be the eclipse. Usually it's hard to for circle, right? For circle, you need to your total energy just the minimum of the potential, which is seldom that it will occur. So usually, all the natural orbits should be ellipse. Okay, so the answer is C. The answer is C. Okay, and I think it's enough for today. I will see you guys in the next video.